We got the 60-minute IPA times 2. All right, let me pull some notes here. So we have some really cool stuff here. So has anybody seen Apple Intelligence?
They are late. Samsung already did it.
Big picture is what's going to happen is nobody's buying iPhones anymore. And so Apple needed something new. And they couldn't buy OpenAI. So they're going to basically exclusively partner with them. I'm not going to buy their new phone because I only like small phones.
There are small iPhones.
Yeah, I like my my mini or my
I
13.
like my Mini too.
Do you have a mini?
Yes.
I have huge hands and I can barely fit the mini and go all the way up and down. So I don't know what other people are doing. Are they using 2 hands all the time or like?
Okay, it's interesting. I do have small hands, and also the new iPhones are bigger than my face, so I prefer 13 mini.
So there's a good reason for them to do this. So they came out with this crazy idea that they're going to do ChatGPT built into the phone. Now, this is a huge concern because they're going to use it to replace basically Siri. And then your Siri request, that means the word, your voice, everything is sent to Apple. But now they want to do all this creepy stuff with it because they want you to just send everything, like your whole screen to them. That's what they want to do. But there's going to be really cool stuff that comes out of this. You're going to be going like this. You're going to take whatever's here and you're going to click on ChatGPT. You're going to say, do my blog post. And you're going to drop that photo in. See how fast that was that I could just make ChatGPT go write my blog post? It's like that, except instant. You don't have to wait. You don't have to screenshot it. You don't have to drag it in. You don't have to do anything. It's just going to run all the time. How's it going to run all the time? Well, it's got to connect to the internet. It's got to send whatever's on your screen constantly to the internet, to Apple. That will be cool. That will help you. But obviously, there's a larger privacy concern that even Apple can't ignore. So they put out a blog post. This is kind of like a V1 white paper, and they explain private cloud compute. So we'll go through this a little bit. This is a fun call today. And then also, I want you to pick up on this stuff because really what Apple is proposing is a blockchain-enabled, zero-knowledge proof, secure, DPIN device for AI. I mean, these are all the buzzwords that I've had in my circles for the past 5 years, and they're actually deploying it. The only thing that this is missing is NFTs. Like, this is everything in the past 5 years. I don't think there's any other buzzwords you could shove into this, but they're all there. Now, the cool thing about this letter is that it does not say blockchain, AI. It doesn't even say artificial intelligence. They just call it Apple Intelligence. So they really are just smashing through all these keywords. Why? Because they don't want any baggage. They want to sell it anew. They want it to stand on its own merits. And I think that's fair. I think this is the right way to do it. And what they're doing hasn't been done before at this level. I've read the whole thing. I'll tell you what's really going on here. And then we can think about how we feel about this. Sounds fun? Here's the problem. We're trying to take your phone and you got a question. You're going to talk to it or you're going to take a picture of something and you're going to say, hey, bro, what's this? That's your query. Right now, you can do this on Google. You can open Google, the Google app, you take a picture. But Apple wants to have this first party. So before you even unlock your phone or even before you take a photo, maybe it's watching all the time, dark mirror. Now, the problem is this stuff cannot be done on your phone. Your phone does not have enough power to run anything close to Llama 2. So it's got to go off of your phone. That's a little dangerous, okay? And what they want to do is they want to have this in some way. They want to convince you that Apple's not going to get your stuff. They're not going to look at stuff on your phone or listen to your voice when you don't want them to. That's what they want to convince you. And so Apple, obviously, they don't want to sell you a box. They want you to have a cloud something.
User behavior, of course, I would prefer to use it Siri. GPT works on your phone, right? So if I am a lazy user, let's say, I don't know that much about the technology. I haven't uploaded the ChatGPT to my phone. I don't know even how to use it. But somehow I have this new feature on my phone. I would like it.
A lot of people are going to like this. Apple is promising that they will allow you to use these models and get all these great answers without Apple being able to see the content of your questions. Tornado asks, where's it going to train its data? Probably going to train it off your voice. So what we're talking about here is something bigger than Siri. Siri obviously is a large language model. Not as big. Apple has championed on-device processing. This is true. A lot of their stuff has been on-device. Image search is done on-device. Image search is an amazing Apple product that nobody even gives them credit for. Now they're saying our next best approach will be end-to-end encryption. So cloud service end-to-end encryption. We want to process data temporarily.
But there are also other encryption models. It doesn't have to be blockchain, right?
Oh no, this is going to use blockchain. I'll show you.
Is it?
Mm-hmm. So we're not up to that part yet. So right now they talk about end-to-end. This is what I want. I want to buy something, put it in my basement, run Llama on it, and just have my phone connect to my Llama and help me. That would be like a confidant. That would be like my assistant. However, for a cloud service, they have this new concept called ephemeral. Is like Tails. Anybody use Tails?
I do remember the Tails. Like many years ago, one of my friends just gave me Tails.
That's it. Yeah. So you have the little USB stick and you boot on it. It doesn't use your hard drive. So the whole point of that is so that when you turn your computer off, it's gone. There's no logs. Everything's forgotten. So Apple would like to use that approach. Just saying that doesn't do it. So they're giving the ideas that they want. They have to go engineer a solution that satisfies these requirements, right? So now the problem is cloud AI security and privacy guarantees are difficult to verify and enforce. When something is difficult to verify, we're almost getting to a trust situation. So keep that in mind. You've got the master of trust on the phone right now. Next, it's difficult to provide runtime transparency for AI. That means we don't know what's running on the computer. So trusting them and what software they're running. On-device computation with Apple devices is possible. The privacy advantages are clear. Users have their own devices, ... However, for more sophisticated requests, Apple needs to enlist help, that's cute, from more complex models in the cloud. That doesn't have to be in the cloud. It could be in the fog. It could be in your own house. But yes, more sophisticated requests require enlisting help from larger models somewhere. There's a legitimate reason why Apple needs to send your data somewhere. These cloud requests live up to the guarantees that people expect. Traditional cloud model is not a valid starting point. So this is a great introduction. They're telling you why we need to do this, why we need to take your data wholesale and ship it off to the cloud. There were a couple hint words on there why we're going to have something like blockchain. Did you pick up on them? Something trust.
Just I want to ask something about the last part.
Yep.
So it is saying it requires different cloud computing system or whatever. So it refers to the DePIN, right? DePIN.
Could be.
It is like the same how DePIN works, because when we talk about cloud or the data saving in somewhere or whatever.
Great question. So in order to process more sophisticated requests, something that can't be done on your phone, this software needs to use a larger, more complex model. DePIN solves this problem. DePIN is one solution. Cloud is the other solution. So in the cloud, that's CPIN, centralized public infrastructure. DePIN is decentralized infrastructure. So now that we have the problem statement, is we need to have something that is some type of secure. We're going to have here some requirements. We're going to spell out what we need the system to do. Stateless computation. This means that the request comes in, you process the request, and then it's gone. If with a human, you would have to have a conversation with somebody with amnesia. And you say, how are you? And they say, great, what's up? And then you say, I'm doing awesome. And then they say, who are you again? That's amnesia. That is how this works. This is called stateless computation. Stateless is a really powerful concept. That's why we use REST. Enforceable guarantees. It's a really strong word. Really strong word. When something is technically enforceable, that means that we can constrain something and we can prove technically, mathematically, that something is constrained. So those are the basic ideas. Now we get into something more specific that really only applies to a large cloud like Apple. Because this is going to cost billions. This is lots of money is going to go into this. This is smart. This is also called security in layers. So we've already got a system that's stateless. It's not remembering anything. And there's some guarantees involved. And we don't have access to the system. Even if somehow it was compromised, we want to limit the compromise. One of their design goals is that if one of the things gets hacked, because there's going to be hundreds of these servers, thousands maybe, we don't want to be able to use this hack to get into Tim Cook's account or any specific person. We don't want to be like, okay, well, I got into this account. How do I get Tim Cook's stuff and then take over all of Apple? How do I do that? So they specifically want to avoid that. Okay. We don't know how yet, but we'll talk about that. Verifiable transparency. Now, here's a second ding, ding, ding. Here's another blockchain keyword you want to see. Verifiable transparency. This is the second one. You've already hit 2 bells. This is going to be a blockchain solution. Security researchers must be able to verify the privacy guarantees matching the public promises. This sentence right here just screams blockchain. Somebody needs to verify that what they're doing, what they're actually running on their computers, matches the public guarantees.
There's a public record of the transaction.
And then it makes, here it is. They must be able to verify is actually what's running on the server. So that's the end of the requirements. And they say this is an extraordinary set of requirements. I agree. This has not been done before. All right, so now here's the introduction. Here's the white paper. Here's the solution. Here's the solution. We're going to get it. Introducing private cloud compute nodes. And the way they're going to do this.
I mean, is there something low or something why we have public-private thing that they what we were calling public data or whatever?
Yeah. So they call this private cloud compute. So they're going to make some software and they're going to tell you, we promise that this software that we're showing you is running on this computer.
But why do I need a public record then? I mean, they're not taking any data, even they are using cloud computing. It's a bit.
Yeah.
So here is the problem. It says that everything is going to be. We say there's a stateless competition on personal user data. So it means that the Apple is nothing to do with my data, my personal data, or somehow as an individual, they're trying to protect me. And there is no server, it's going to keep my data because there's no privileged runtime access and non-targetability. That means they are not going to keep it, but they are going to then save it on the public.
No, you're close. So the data is private. The data is yours.
All right.
The software that's running is public. It's really easy for Amazon. Amazon runs the cloud. They run all the cloud. And Amazon can say, you know what? We're not going to keep any logs whatsoever, like VPN. So the VPN says, we're not going to record anything. End result, they record everything. So it's a lie. They don't tell you who's running it. You send all of your data to the VPN, and now you're just giving it straight to the FBI. Just because they tell you they're anonymous does not mean they're anonymous. Just because they tell you they're not storing logs does not mean they're storing logs. Apple says we need to do better than this. We need an enforceable guarantee. When a VPN says we're not storing logs, that is not enforceable.
So something on just took my focus on non-targetability topic. Something as certificate is issued for keys rooted in the secure enclave UID for each PCC node. Private cloud computing system.
Yeah.
What is to do with the validators? Yeah, I mean, there's also, as I understand, then Apple itself validating all the data itself for the computing. Are they going to have their own cloud?
Yes, they will have their own cloud. So that in general, broadly, what the solution will be is Apple will spend billions of dollars. they will buy lots of NVIDIA chips, probably Apple chips, and they will have lots of Apple servers running special software to respond to your request. They have to do a better job than the VPN proving that what they're running is actually what they're running. But I'll just start intuitively. Here's the Apple iPhone. It's very difficult to break into the iPhone if it's off. What's going on with an iPhone? There's a chip inside that is specifically responsible for signing software. The software that runs on the phone is verified that you're not running software that Apple or you don't want to run on your phone. And this is why you don't steal iPhones. Everybody knows that. You don't steal an iPhone. They block it. You'll never use it again. It's never going to run anything. The whole point about Apple is they want to make a special operating system that does not have backdoors, doesn't have an admin account, doesn't have any logging. It's basically like Linux Tails. They want to make an Apple version of Linux Tails, and they want to sign it, Apple's key, so that it can run on Apple servers. They're going to publish the software. You can see it, and you can see there's no backdoors. You can review the code. You can run the code, whatever. Well, the hacker's at. What's wrong with this? The problem is the same thing. Somebody kidnaps Tim Cook, beats him over the head with a $5 wrench, and then he gives them the password. Now they just sign another software. Apple can sign the software. The FBI asked Apple to sign the software to unlock iPhones. Apple said, eat it. What if Apple said, okay? If Apple can sign the good software to put on the server, that means Apple could also sign the bad software and put that on the server. Does that make sense? The same security issue here, keeping your iPhone safe as the private cloud compute.
You think they signed over software into updates that, three-letter agencies can get at?
I do not think that they signed those bad, malicious updates. So they don't even want the possibility of this happening.
So public key then, or what?
Yeah. So this is where the blockchain comes in. This is a blockchain type of problem. The problem is, in general, the problem is, did you or did you not sign some bullshit software that should not be running on the server? If you access Google in China, they spoof the Google website and redirect you to Baidu. So you think you're accessing Google, but they man in the middle you. So then the question here, from a security standpoint, is did a certificate authority or did they not sign a bullshit certificate for Google? That's the question. Did or did not somebody sign a thing? That's blockchain, baby. That's so easy. Every time you sign something, you put it on the blockchain. And there's no erasing that. If you sign it, we know you signed it. You blockchain it. There's no denying it. So the whole thing here is called irreputability. So that is the blockchain. But Apple's not going to call it blockchain. They're going to call it append-only, cryptographically tamper-proof log. That's a blockchain. That is blockchain. So basically, all the code is going to be blockchain secured. Doc 72. When you use a whole paragraph to describe what is a botnet, they're absolutely trying to avoid the word. However, I agree. You should not use the word blockchain. The blockchain has baggage. Okay, so they're basically using a blockchain to mention all the times that they sign a software. So blockchain saves the day. This is a very high level thing. There's more to come. I think this is appropriate for them to put this blog post out. It gives us an idea of what they're doing. Now, there is one last hack. There's one last vulnerability about this whole system. Assuming everything Apple said is true. They have their system, they sign everything, there's a blockchain, they can't hack their blockchain. They only run the software that's signed. There's still a fundamental problem with this idea. Doc 72, let's go. Who manufactures the chips? That's right. This is all dependent on the chips running. There's no supply chain verification for the chips.
It's going to be in Taiwan. So just a minute. Apple is going to use Google chips, but are there any Google chips anyway? Do they already start developing it?
Apple designs their own chips. They outsource manufacturing. They do not have a foundry. As far as I understand, these chips are sent to Taiwan Semiconductor Manufacturing Corporation, and then they are sent to Foxconn to assemble, which is just, physically assembling. I don't think the M3 or M4 chip is going to be sufficient to run these workloads. I think they're going to have NVIDIA chips. Now, luckily, they did have a consideration of this concern because they did say, even if there was a supply chain security issue that was able to interdict bad chips into their supply chain, at least the impact would be limited to which specific chips were there, and you could not use it to target attacks. No, there's no way to prove any of this. There is no way to prove anything, and it's very easy to show that it's not provable. If this was secure, then Apple would send the chip to your house, and they would have Apple's security key in your house, and you couldn't access it, right? But it's not like that. Instead, you send your private stuff to Apple, and they can't access it, right? You do not need to be an expert on any of this stuff to appreciate what's going on here and to participate. Be careful. Don't trust anybody. Verify, and then just study this stuff. But then also thank them. Thank you, Apple, for at least putting out this article. Thank you for not being a dinosaur, and hopefully thank you for investing billions of dollars to deploy OpenAI Stack across your own servers. And thank you to everyone here. So thanks for joining the call. Take it easy, and I will catch you next time.